How to Test This, the podcast designed to help software testers understand risk and adopt new testing solutions with ease and confidence. Your host is Mahamadou, a quality assurance consultant with over 10 years of experience across multiple industries. In each episode, he'll talk to different experts and learn from them about how they test.
So thank you and welcome to this new episode of How to Test This. My name is Mamadou and I have James Bach as a guest today. So James Bach is a legend of the testing. He's a consultant, trainer, writer, founder of RST Methodology. He's been around for a long time, since the 80s. He's a trainer. He has a website called RST when he teaches about this methodology. And he is a co-author of the book, Taking Testing Seriously, the Rapid Software Testing Approach. So thank you very much for being here, James.
Thank you for having me.
Yeah. I have a few questions to ask you so we can get to know you. Can you tell me about how you moved from programmer to tester to the founder of RST Methodology?
Well, after I quit high school in the early 80s, I got a job at a office supply store that sold computers. And I was supposed to sell computers, but I never sold any computers. And I broke one. So I was -1 on on that. So I hated that job. But somebody walked in one day and they asked me if I knew anyone who knew assembly language programming on the Apple II computer, and I did know how to do that. And I showed him some of what I did, and he hired me to be a video game programmer. So that was how I became a developer. I was a developer throughout my teen years. And then I burnt out. I got very quickly tired of writing code for a living, but it was my only skill. So I was kind of stuck. And then Apple Computer found out about me and invited me to come and be a test manager in the development systems quality group at Apple Computer. So I joined Apple Computer. This is my proudest achievement in my life, is that I was the youngest manager in the R&D division at Apple Computer in 1987. I was 20 years old when I was hired. And that's when I really feel that I got serious about having a career. That's when I fell in love with testing. I decided I wanted to be very, very good at it and started studying it. And as I say in my book, taking it seriously.
Thank you. And you also said you're influenced by Jerry Weinberg and Camp Kainer. Can you tell me about that?
Yeah, I ran across Jerry Weinberg's work when I was trying to learn to be a manager. I encountered one of his books called Becoming a Technical Leader. And I loved the non-patronizing, non-authoritarian way that he wrote. So I started reading more of his books. And finally, I met him online in the early 1994. And he liked some of the things that I was saying online. And I sent him an article I wrote, and he said he liked it. And I was very thrilled because Jerry was more than 30 years older than me. And he was telling me that what I was saying was helpful, and that it gave me tremendous satisfaction that someone like him would think that I'm smart and not stupid, helpful rather than being unhelpful. So I took all of Jerry's training the classes that he was teaching at that time, which were all about understanding how psychology and engineering go together. And this profoundly influenced how I think about testing, and especially one of his lesser known books called Introduction to General Systems Thinking, which to my mind is the fundamental textbook of software testing. It was written in 1974. It doesn't mention software testing, and I think of it as the fundamental textbook of software testing. It teaches you how to think critically about technology. So, yes, Jerry's work profoundly influenced me, and everything that I do is like an elaboration of what he was doing. And then
Okay.
so he was kind of like a father figure to me. Kem Kaner turned into kind of a big brother to me. So I had read Kem Kaner's book, Testing Computer Software, and he had left the industry in the early 90s. Kem had gone to law school, and he wanted to be a lawyer. But that didn't work out. I mean, he became a lawyer, but it turns out they didn't like the way law firms operated, so he came back into the testing world, and so he met me, and we became friends and collaborators. And I was talking a lot about exploratory testing, which he had written about in his book. And I had become very associated with exploratory testing. So, in fact, I had become so associated with the term exploratory testing that for several years, Kem thought that I had coined the term exploratory testing when in fact he had coined the term exploratory testing and he'd forgotten that he'd done so. So I thought I did because he told me I did, and I thought he would know. Uh, but then he reread his own book one day and realized he had figured it out several years before I did. So Kem taught me a lot about rigorous thinking and academic rigor, and pushed me to study testing more deeply than I ever had before. He was a great influence that way. So I collaborated with him for about 15 years. And while I was developing RST, he was continuing to develop his methodology, which is called black box software testing. And we also co-founded the context-driven School of Software Testing, and we co-founded the Association for Software Testing, both of which were his idea. But I was right there with him during that process. Kem used to be a very important leader in software testing. He's retired now, so he's given all that up, but that's a shame. I'm never going to retire myself. My retirement will be on the day of my death.
Totally understand. And what observation or frustration led you to create the RST methodology?
Well, the complete ignorance of the people who were writing testing books. It drove me crazy. Testing books written in the 1980s and before that are mostly completely ignorant about testing, because mostly they treat software testing as if it were a computer science problem. But it is not a computer science problem. It's not primarily a technical problem. Testing is a critical thinking problem, and it's a social problem. We're not trying to find the perfect formula that will somehow find all bugs. We're trying to understand complex systems as they evolve, and understanding what problems these systems might have in all aspects of the meaning of the word problem. So Jerry Weinberg understood this. Jerry Weinberg had been a programmer at IBM and was completely in the world of programming and had participated in the development of the fundamental computer systems and operating systems that made the world. And Jerry understood and wrote in 1961, wrote in one of his books about the nature of software testing. And he understood that it was about complex systems and people and problem solving and systems thinking, all that sort of thing. But the books that were available in the 1980s just talked about writing test cases as if that was going to solve our problems. Just write test cases. Well, my question is, which test cases am I supposed to write? And the books never had an answer for that. Oh, just boundaries and read the spec, and as if that just answered all the questions. Well, if all I do is read the spec and think of boundaries and equivalence classes, I can create an infinity of test cases that way. That doesn't give me a basis for practical software testing. And so if you take most testing books and you can take almost any book about testing, not every book, but most books about software testing, you can open it up, you can go through the whole book and just keep asking the question, where is it going to tell me how to test this product? Where does it actually teach me how to test? As opposed to saying, this is what your test case template should look like. Well, okay, that's a template, but how do I actually test? Very, very few books teach you how to test. My book, Lessons Learned in Software Testing, tries to teach you how to test in a certain way. I collaborated on that with Kem Kaner and Brett Petticord. Kem's original book, Testing Computer Software, tries to teach you how to test and talks about what testing is like and what kinds of thinking you have to do good testing. The book, The Art of Software Testing from 1979, talks somewhat about how to test, but then quickly goes into these techniques that are mostly not applicable to real life software systems, and assumes that you have a complete specification, which you almost never do. But it did have The Art of Software Testing, is a book that has some information in it about the mentality of software testing. But that's what I was frustrated with. And so I wanted to change people's relationship with testing. I wanted to encourage the development of craftsmen who understood critical thinking about complex systems and the psychology of that and the sociology of that, because that's how we're going to find real problems that get reported and get fixed, hopefully.
Exactly. And now you're working as a consultant. What you're doing is solving problem people don't know how to solve. Can you tell us about that?
Well, for the last 25 years, I've been an independent tester and testing consultant, and this sometimes, mostly what that is training software testers, coaching them, training them, helping develop them into better thinkers. But there are sometimes I'm hired to help a company create a better testing culture. Sometimes it's that they feel like they have lots and lots of test cases, but they're not doing good testing. So they have me analyze their test cases and suggest ways that they can do better testing. Sometimes it's about automation. Sometimes it's a very specific kind of analysis. A company hired me recently because they were worried that they were using illegal test data. So they wanted me to find out through interviewing and any kind of scanning that I could do to discover if they were using test data that they shouldn't have been using. And now it's AI. So I'm maybe working possibility of me working with a big company that's trying to apply AI to everything, and they need to test that AI. So Michael and I may be involved in helping them find good ways of doing that. That's the big challenge of that's a big need, I think, for test consulting right now, is to figure out how to integrate AI with responsible software testing.
Okay. And you wearing multiple hats, and one of them is a trainer. Can you talk about the state of education nowadays as a QA or tester?
Well, there's a lot of bad classes out there. There are a lot of YouTube videos promoting misinformation about testing, lots of folklore that isn't particularly helpful. A lot of stuff about testing is all mixed in with other things that isn't testing. For instance, some people, when they teach about testing, they can't seem to resist changing the subject to quality and creating quality. I think there are a lot of people who, for some reason, they call themselves testers, but what they really want to be is project managers and designers. They want to create quality, which is fine. My job isn't to create quality. My job is to understand what the quality is. I can't be distracted by having to create the quality. That's a huge distraction. It stops me from being able to understand what the quality is if I'm worried that I have to fix the bugs or prevent the bugs or whatever. So I'm not against bug prevention. I just think it has nothing to do with software testing. And a lot of the classes talk about software testing that way. Then there's the ISTQB, which came into the world somewhere around the year 2000. I don't know exactly when, but right from the beginning, it treated testing as a silly, shallow process, and they've really messed up the industry. There are people who feel like the ISTQB certifications are important to have. They're totally unimportant to have. You do not need an ISTQB certification. In fact, every single person who gets an ISTQB certification is contributing to the low standard of education in our craft, because the ISTQB is not a research organization. They are a money-making organization. They did nothing to advance the state of the art. They've never done anything to advance the state of the art. They are a pure parasite on the field. But they spend a lot of money on advertising because they're basically an advertising company that is connected to software testing. They tried to recruit me toward the beginning when they were first expanding into America, and I told them to go to hell. So I missed out on making all that money.
Yeah.
But there's a problem I have with money making. It's a fundamental flaw in my character, which is I don't feel comfortable telling lies. And so if making money requires me to tell lies, then I have to not do that. And that's why I'm not particularly rich right now. There's not a
Yeah.
whole lot of demand for someone who absolutely always tells you what he really thinks. That's Only a few very discerning clients want that particular brand of wine.
Yeah, totally get it. Now we've talked about you. Let's talk about the current issue with the testing industry. First of all, can you define what is testing lightly versus testing seriously?
Testing is a process of evaluating a product by learning about it through experiencing, exploring, and experimenting with it. That is our definition of testing in RST. So testing is always a learning process. It's a human learning process. It's always an evaluating process. If you're not learning and you're not evaluating, you are not testing, according to me anyway. But testing requires that you experience the product as well as explore it, as well as experiment with it. And so merely writing some test procedures does not quite qualify as testing, although that can be part of testing. Our definition of testing is human centered, because when we say taking testing seriously, what we're trying to say is it's not enough for us to treat testing as theater, as some just box that you check off. Oh, I can say that I did testing, so I must be okay. We see testing in terms of its mission: to find important problems before it's too late, to inform our clients about the status of the product so that they can make the decisions they need to make. If you really want to do that, that's what we mean by taking testing seriously. If you really want to find bugs before it's too late, what is it that you have to do? And it seems to me that a lot of companies, instead of taking the attitude of let's find every important problem before it's too late, they take the attitude of let's create a lot of test cases so that we can have an excuse to ship. And that if we ship and there's bugs in our product that we didn't found, we could just say, oh, it's not our fault. Technology is hard. Or maybe they just blame the testers. Oh, the testers didn't create enough test cases. It's their fault. It's not our fault. But when you run a business and you want to deliver a product that you promised to deliver, a good product, a product that people are purchasing, that you have contracted to give them, and if you want them to get that product, well, then you have to take testing seriously. Then you have to actually do testing. You need to actually evaluate the product, and that is going to be a learning process because the product is complex, and you're going to have to explore it. You're going to have to experiment with it and experience it. There's no magic button that gets you around this. Ultimately, testing, taking it seriously, is a responsible process where some human must take responsibility for the work. That's how we approach testing.
Okay. And since then, you have created the RST methodology, you claiming it's fast, inexpensive, credible, and uncountable. Can you tell me about that on how it's different from other methodologies?
The biggest way that there's a number of ways that it's different, but I guess the biggest immediate thing that's different about RST versus so-called traditional approaches to testing is that RST is tester centered. In RST, the tester is in charge of the testing. The tester controls the testing. Other methodologies are test case centered, and they say the tester's not important. What's important are the test cases, what we call artifact-based test management. Whereas my approach to test management is activity-based, and activities are things people do. So that's the biggest immediate difference, is a complete recentering of testing from test cases and from being a mechanical process to testers, and for testers to testing to be a social process instead of there are also technical and mechanical aspects to testing, but those are on the outside. Those are on the periphery. In the center of testing is the notion of the tester, the person who is thinking critically about the technology. And everything must conform around that central figure that we call the tester. So I use tools, I use automation, but the automation and the tools are not doing the testing. They're helping me, the human, do the testing. I do the testing. Similarly, you might have an artist, and the artist uses paintbrushes. Well, the paintbrush isn't making the art. The paintbrush allows the artist to make the art. Nobody speaks about automated art using automated paintbrushes so that we don't have to deal with artists anymore. No one thinks about it that way. Art is always about the artist. Similarly, parenting is about the parents, and management is about managers, and testing should be about the testers. The main reason we say that we would call it rapid is because in rapid software testing, we encourage testers to eliminate any process which is slowing them down and is not needed. So one of the reasons why testing can be slow is people are following, quote, best practices that aren't helping them. And we suggest you just get rid of those things. But a corollary to that is sometimes rapid testing ends up being slower than other testing methodologies, because it's become slower when you realize we have to be careful right here. It says same thing with racing a car. If you want to win a car race, you don't just put your foot down on the gas pedal and never let up. Sometimes you have to press the brakes and slow down as you're coming into a turn. Otherwise, you're going to fly off the turn. So part of rapid software testing is knowing when to take more time with something than someone else might take who doesn't understand the testing problems.
Okay. And nowadays, we see a lot of programmers doing the testing. What do you think about that?
Well, anybody can do testing. That's not a problem. Users can do testing, managers can do testing, anybody can do testing. However, not just anyone can do systematic testing. Not just anyone can do excellent software testing. To do excellent software testing, that requires skills, and it requires motivation, and it requires time. The problem with programmers doing testing, developers, well, let's just say programmers. A problem with people with coding skill who do testing can be that they lose empathy for the user because they see the product in terms of code instead of seeing it in terms of the experience that users have. And this is a problem that I have. I'm a coder, and it's something I struggle with, that it's very easy for me to fall into a technical view of any product that I'm testing and not see it as a user experience. So I have to remind myself of that. I need to be hanging around people who maybe are not coding testers in order to prevent myself from falling into that trap. But then there's another problem where developers are testing their own stuff. And there's a big problem with developers testing their own stuff, and every developer knows it. Every developer knows that their highest priority is not testing. Their highest priority is delivering. And they're worried they're not going to deliver. So are you really going to spend time testing when that means that you are spending less time developing that next feature that you have to have ready by Friday? Really? Developers find lots of reasons not to do deep testing. Even though they could do it intellectually, they're not rewarded for doing that. And so they tend not to do that. They tend to do what they're rewarded for. That's why it's so important to have independent testers, because independent testers are rewarded for doing testing. We're rewarded for finding bugs. No developer is ever rewarded for finding bugs in his own product. In fact, all he's going to do is get people to say, oh, well, you didn't do it right the first time. I guess you're not a very good developer. So when I was a developer, I didn't like testing, and I postponed testing as much as possible. And then I became a tester, and now that's my job. And I realized I like it better than development.
True. And as a tester, why it's important to understand cognitive bias, decision-making processes, or human perception?
Why is it important to understand cognitive bias as a tester? Well, it's like, why is it important as a dancer to understand nutrition and exercise? If you're going to be a dancer, you need to be in top shape. If you're going to be an athlete, you need to be in top shape. You can't just eat candy all the time and expect that you're going to be a fantastic runner of marathons. So you need, bodily wisdom if you're going to be a top athlete. Well, you need wisdom of the mind. You need wisdom about thinking if you're going to be a top tester. A tester is an excellent tester is a finely tuned instrument of perception and reasoning and critique. What kinds of things throw us off when we're trying to do that? Cognitive biases are amongst the things that throw us off. So we need to understand how our thinking might be impaired by cognitive biases so that we can take some action to counteract those biases.
Okay. And what do you think about the current way of testing nowadays with tools like Jira that are very popular when we work on tickets and complete them and go to the next ticket, for example?
Well, Jira is not a testing tool, and the people using Jira, unfortunately, makes it easier for management to turn the development process, the design process, and the testing process into a bean counting exercise instead of, and that distracts people from the things that make software projects successful. You need ideas. You need to be able to experiment and try different things. You need learning. That's what makes software projects successful. Does Jira help us do any of that stuff? Really, it doesn't. All Jira is an elaborate set of to-do lists. And to-do lists don't build software. So I think that this that the widespread use of Jira tends to squash software testing. It tends to squash any creative, deep intellectual process. And everyone who enjoys doing deep thinking and creative work and high level design works, every single one of those people, I suspect, would prefer not to use Jira. I don't know any tester or designer who says, my testing's so much better now that I'm using Jira. But managers like it.
Yeah, understood. Now we talk about what it means to test. Let's talk about the different risks we can face nowadays in the software development. According to your experience, what's the most overlooked or unseen risk with software development?
You're asking me what's the most overlooked risk with software development?
Yes.
Well, I don't know if it's the most overlooked. Might be. I mean, there's an obvious answer to that question, which is security. Why do we, after 50 years, 60 years, 70 years, why are we still having so much trouble with security in our industry? Why is ransomware such a big business? And part of that answer is developers don't take security seriously. It's an overlooked risk. They think, well, it's not gonna happen to us, or we'll just use the common libraries everybody else is using, and I guess those must be secure because everybody's using them. So I think security is the big overlooked uh, risk. A secondary one is usability, um, but the one that I look for and that I'm going to find every time is problems that happen because of a variety of data, some strange data that you give the product that causes it to behave differently than you expected. A typical thing with most approaches to testing is to focus on test cases, but not so much on test data. I focus a lot on test data. I'm mostly interested in that because I find that consistently I will find my favorite bugs by creating a wide variety of test data to test with, and then trying things that are a bit unusual, and thus running into all manner of problems.
Do you have an example of that?
Oh, well, I mean, sure. I was using Claude Code the other day. I use Claude Code a lot to create little test tools. And so I have one test tool, which is it watches a database. So as I am running my other test activities, I'm going to an API and I'm interacting with an API. Every single thing that I get, that I send to the API or I get from the API, I store in a database. So I always keep all of my output data, all of my input data, everything gets stored in case I need to go back later, because I might find out about a bug later on, and then I want to know, when did I first see that bug? And I always have my history that will allow me to uh, find that out. So I asked Claude Code to give me a viewer program that would view that database so I could keep track of my various test programs as they were running. I could see what was going up and down to the API. And it gave me the program, and then it made it so I can see the last 100 items. So I said to Cloud Code, well, I want more than 100 items. Give me the ability to type in any number I want, or give me a drop down or something. So it gave me a drop down. Now I can look at 250, 500, 2000, 2500. So I got this little drop down. But as I was using the program, I found out that it gave me that additional feature, except that if I tried to go to see any more than 100 items and I clicked on one of those items, it would not be able to retrieve it from the database. It would give me an error. But turned out that it had given me the ability, it had added the code to bring back the summaries of all those things, but didn't change the part of the code that let me look at the detail. And that's a very typical kind of bug. But you're never going to notice that unless you test with a situation where you go past 100 items. So you're not going to find this in a sanity test where you just click on the first page of items and you go, yep, everything worked. You have to go into a more exotic scenarios. That's an example of a typical kind of bug. And when I'm working with Cloud Code, I expect that it's going to produce things that pass sanity tests, that like basically work, but I immediately have to start giving it different kinds of data. I need to give it data that has Unicode characters in it, because then I'll find out that, oh, it doesn't handle Unicode characters.
You have HTSM as a cornerstone of your methodology, RST. Since we don't have unlimited time or resources, how can this tool can help us prioritize our testing?
The HTSM model is an example of what's different between my methodology and others. The HTSM model is a set of heuristics. It is not a template. It's not a set of rules. It's a set of what are called guide word heuristics. So if you work through the model, what the model's trying to do is it consists of a set of words and phrases that are meant to jog your mind so that you don't forget when you're under pressure something important that you were supposed to be thinking about. In this way, it helps you think of the right kinds of tests at the right time. Now, you can use the Heuristic Test Strategy Model to take a long time to test. You can go through every single item in the HTSM model and extensively research that item with respect to the particular product you're testing. But the way we designed it so that you don't have to go through it element by element. You could test the product interactively and intuitively, letting whatever ideas come to you that you like, and then at the end of that process, after an hour or something, then go through the HTSM quickly and say, is there anything here that I think I still need to look at that I've forgotten to look at? That's the HTSM. So you can use this model in a quick way, or you can use it in a slow and super methodical way. It's up to you. It's up to each tester. It's not, some people say, well, we should have a list of standard test cases that we always run. And if you really did have that list, you'd have two problems. One is it would be a very long list. And two, it would be a list that would be wouldn't pertain to every different situation, and it would be a list that would become obsolete quite quickly. So with the HTSM, we have focused on a small set of things that are more or less timeless. We update this every so often. We most recently updated it earlier this year, and we've been updating it for more than 20 years.
Okay, got it. And can you also share some tips about how to perform deep testing?
Deep testing. Well, deep testing is one of those things that it's you need more than tips to do it. Deep testing means testing that is especially thorough, that is that maximizes the chance of finding every important bug of a particular kind. So every kind of deep testing is different, is specialized to the specific thing that you are testing. To get into deep testing, you not only need to learn various techniques like combinatorial testing. If you're going to get into deep testing, it's always every deep testing that you do is specific to the particular thing that you are testing. And you apply all of the ideas and thought forms of testing. For instance, you need to be able to think about coverage. What is there to test, and what will you look at? How will you get at that thing that you need to look at? Let's say you're trying to do deep testing of a chatbot. It's quite difficult because, for instance, if I want to ask a chatbot for technical support about the details of a warranty, well, there are lots and lots of different ways I can ask about the warranty. I wrote a program that generated 9,500 different ways to say, please tell me about the warranty. Well, I don't have time to do it. Would be very deep testing to just run it through every single one of those questions and then check the answer. I don't have time to do that. So part of the art of deep testing is to learn how to generate lots of different test data or test scenarios, and then learning how to sample from that so that we maximize the variety, and then learn how to judge how much is enough. And that is going to be a different, in one sense, it's the same problem for no matter what you're testing, but in another sense, it's a different problem depending on what feature you're testing, what kind of product, what kind of project you're on. That's why we say that we're context-driven testers. I'm a context-driven tester because I don't do the same thing in different situations. I do different things in different situations. And so I have to learn to read that situation and make appropriate judgments. So, tips for doing that. How about practice? How about study? How about try lots of different test tools and test techniques? Hang out with other testers who enjoy deep testing and do testing exercises with them for fun in your own time. That's what I do.
Okay. And another topic, like nowadays we have plenty of tools for everything. And as a tester, we are often overwhelmed. How do you select or utilize tools for genuine experimentation?
Say flawed code that I'm using to develop test tools.
Yeah,
How do
exactly.
I,
Yeah.
oh, well,
How
usually
do you evaluate tools? Yeah.
well, usually the first thing I do when somebody says, "Oh, you should use this tool," is I just try it out. But that's only if I have a friend who says that it's a good tool. Then I'll try it out. If I don't have a friend who says it's a good tool, what I'll do is go and read about it. I usually read about it on GitHub, or there might be someone might have blogged about it, and I read about it and I think of how it might be useful. And if I think it's useful, I think it might be useful, I go give it a try. And as I'm giving it a try and working with it, I'm not primarily looking at is this a tool that's going to um, do some wonderful thing for me? Actually, what I'm primarily looking at is how reliable is this tool? Because I don't want to waste my time on tools that are going to let me down. I need to have tools that I can rely on. So I have to develop a relationship with the tool where I trust it. And that's the main thing. I have to trust it. And then I have to think, what is this good for? And then I have to remember to use the tool when it is necessary. And this is, in some sense, the hardest part. There are so many tools that I have that I use, and so many that I should use, but I've forgotten about. And so this is a problem I'm trying to solve right now. I'm trying to create for myself a catalog of tools that I need for different reasons. And I have to put this in somehow into a catalog, into some documentation that will help me remember all the many tools that I have, because I have hundreds of tools. And it's so easy to forget that you have a tool that can solve a certain problem. There are some tools that are useful for lots of different things, and I treasure those tools. I mentioned Cloud Code because that is one of the very few tools that I pay for and that I think is very helpful. I also Snagit is a tool that I pay for and I think is very helpful. Most other tools that I have, I don't pay for, but there are some of those tools that I think are fantastically helpful. And one that I suggest that any web-based tester should learn about is a tool called JQ. JQ is a tool that manipulates JSON data structures, and I use it a lot as I am doing deep testing of web-based products, because they increasingly use JSONs to exchange data. So once I hear about a tool, somebody tells me about a tool, I try it out, I have to learn to trust it, and then I have to remember to use it. That's kind of the cycle that I go through.
But I believe your checklist of all the tools you're using could be definitely helpful for many people.
Well, I do have a list, which I'm happy to share with you, which is my favorite free tools. I do have that list. And that list doesn't include all the tools that I've written, however, because that's, there's so many tools that are on my disk that I wrote for some particular purpose, and then I forget that I have. But I do have a list of my favorite free tools. I'm happy to share it with you.
Another popular topic: how do you implement automation and AI in the RST context?
I have a chapter on both of those things in my book, Taking Testing Seriously. So yes, automation. I use automation for all kinds of different things. What most people think of as test automation, I call user simulation. User simulation means get a tool to pretend to be a user using the product, and then you exercise the product that way and try to find bugs. And that's an important kind of automation. But there's other kinds of automation that you could be using. Two of my favorite kinds of automation. One is automated data generation to develop test data that I can use then in my testing. And another one is what we call augmented experiential testing. Augmented experiential testing tools are tools that help you explore a product in real time, remembering what you did, keeping track of what happens, helping you in the moment get more out of the experience of using the product. So I have various experiential based tools that I use, such as I have a tool that is constantly monitoring the Chrome debug log and letting me know about certain kinds of events that happen in the Chrome debug log. And I can search the Chrome debug log to find anything that's happened in it in the last 18 months. I keep 18 months of logs on my system. And so I don't ever miss anything. If I don't want to miss it, I don't miss it. Lots of other testers don't keep track of the Chrome debug log. And so there's all kinds of errors that they may be missing if they don't do that. So that's not a classic, quote, test automation tool. It is a tool, though, that helps me do better testing. So I've got tools like that. When it comes to AI, the number one way that I use AI in testing is to develop test tools for me in a few minutes instead of taking an hour to create that tool. So, for instance, I have a tool right now which is monitoring my RAM usage because I was running out of memory. So I asked Cloud Code to create a specialized tool that detects memory leaks, and it's constantly running on my system. That's something that was just an idea that I had, and in a few minutes, I was able to get that tool with the help of Cloud Code. And that's wonderful for testers. It's revolutionary for testers, especially testers that don't have their own programmers and aren't very good at programming. If they can have access to Copilot or Cursor or Cloud Code, something like that, they can create their own test tools. And then it's just a question of asking for what you want, which is an important skill. Every tester has to learn to ask for what they want. So, that's the number one way I use AI. I also use AI to help me analyze products. Sometimes it has ideas or sees aspects of products that I don't think of. So I do my own thinking on that, but I also ask AI's opinion, and I just quickly check to see if there are any ideas it has that I didn't have. And then if there are, then I'll pick those ideas and add them to my work.
Okay, thank you. So now we're going to talk about the last part of this program about upskilling. Nowadays, like, what role do you think would be in high demand in the future as a QA? Because I saw about QA full stack, SDET, quality architect. What do you think the role would be on demand?
I don't know. This industry is insane. I'll tell you what it should be. It should be that testers should be more popular than ever. Because if AI is going to be writing code and AI is going to be designing things, then what you need people who are checking to see if it is really doing that. You need people who think critically about what AI is doing. So by all rights, testing should be entering a renaissance of amazing popularity. But I don't see that happening yet. I mean, it should have happened by now, but I honestly don't see that. And I think it's because the people who run businesses are too complacent. They just think, I don't have to worry about everything. Everything's going to be fine. We don't need anybody to check what AI is doing. Or maybe they think the developers are going to do that checking. Yeah, good luck with that. The people who are best able to do that are people who believe in trouble, who enjoy finding trouble. Those are the people that you need. If you're going to do a lot with AI, you need to gather around you, unless you want to be embarrassed by the poor performance of your AI. You need to gather around you people who love critical thinking and love reporting problems. And that's a testing skill. That's all about testing. But so
Okay.
I don't know. I don't know what's going to actually happen. I can just tell you what should happen.
Yeah. And then if I were to start today my career as a tester, what would you recommend me to do?
I'd recommend that you focus on security testing, probably, because it seems like security testing and security work is very important. And I'd also recommend that you focus a lot on testing AI. Learn a lot about AI and testing AI. If what you want to do is get a job as fast as possible, then I would think that those are the two areas that you'd be most successful at. But it's
And
overall, I'd suggest, have you considered trying a career in the food services industry? I think there might be more opportunity there. Right now, the software development, software engineering world is full of confusion. It's full of layoffs. It is not a friendly place to be right now. So good luck to everybody. But the interview processes are broken. It's ridiculous the kinds of interviews people have to go through. Companies should just hire me to handle all of their recruiting, because I would be so much less expensive. Because I wouldn't require people to go through 10 interviews. It would be like 2 interviews, and then we tell you if you were hired or not 5 minutes after the second interview. It's so easy to hire people, and yet companies turn it into this incredibly convoluted thing. It's like you're trying to get a job as a Shaolin master, and they're putting you through the 11 rituals of pain before they let you have a job. It's absolutely stupid. I used to hire people at Apple Computer for 10 years. I was a hiring manager. It is not difficult to recruit and hire people. The world is awash with people who want work. We do not need AI to help us hire people. We can just go on LinkedIn and you'll find people you can hire in 10 minutes. It should be the easiest process. I don't know why the industry has turned it into this terrible wheel of pain.
okay, okay. And what do you think about projects or certifications as a starter?
I think certifications are worthless, so don't worry about those at all. They do commercial. There's no available commercial certification that's worth anything, as far as I'm concerned. As far as I don't know what you mean by projects. You mean like doing a project?
Yeah, I mean, like having a portfolio when you can showcase your skills.
That I think is very important. I think that's what you should be doing. You should be creating a showcase of your work. That would, if I were a hiring manager, I would be very interested in people who have a portfolio of their work, and I'd put them right to the top of the list. So
Oh,
I've got one of my students doing that. She's put together a wonderful portfolio of her work that she sends out to people, and it's a great basis on which people can judge what she does.
and what would you add in this portfolio? What would you showcase?
It's many examples of doing the most realistic work that you can possibly provide. Now, a problem with portfolios these days is someone might look at your portfolio and think you faked it with AI. That's the problem. Did you just steal this from somebody? So the problem that always hovers over a portfolio is, how much can I trust this? And so that's where the interview comes in, because they have to figure out, well, are you fully aware of what's in your own portfolio? Does it seem reasonable that you did this work? But you got to have as much realistic stuff as possible. For testers, that would be examples of bug reports and test code and test data, test reports, written test reports, product coverage outlines, whatever it is that you think expresses your skill as a tester. You want to provide as much of that as you can so that people can see what you've done, because interviews are not a good way to find out if a tester is skilled. You really have to look at their work.
Okay, thank you. Last question. Do you have any book recommendations or people to follow to get better?
Book recommendations. Well, I just wrote one, so there's that.
Yeah, of course.
Apart from that, I recommend the two other books that I wrote. Absolutely. I wrote one called Secrets of a Buccaneer Scholar and Lessons Learned in Software Testing. As far as other people's books, I recommend Jerry Weinberg's book, Introduction to General Systems Thinking. I also recommend his book, Perfect Software and Other Illusions. What else? Let's see. Are there any other books I would recommend? I recommend a lot of sociology and philosophy books, but no one ever goes and reads them. But I would suggest, if you wanted to understand deeply the issues of automation versus human work, I would suggest reading a book called The Shape of Actions. Harry Collins wrote The Shape of Actions. I think he co-wrote it with another guy. That book helped clarify for me what the difference is between things that can be automated and things that cannot be automated. But I read a lot of things like that. I read a lot of philosophy and sociology and psychology stuff. That helps me to understand the nature of the work that we do better than anything else.
So I thank you very much for your time. It's appreciated. So if you like this episode, feel free to share it with your friends or colleagues. In the meantime, see you in the next episode of How to Test This. This was Mamadou, and see you next time. Bye.